Okay, moving on to number 4. So we have the graph of the derivative. That's super important here to answer the following questions. Okay, I think Colin hand drew this. Let's just ignore it. Let's actually clean this up and say that it's like, it, kind of peaks down there, okay? Does that look a little bit better? Don't freak out on me, okay? All right, so we need to first figure out when f is increasing and when f is decreasing. Okay, remember, this is f prime. Well, these are the slopes of the tangent lines, right? So f will be increasing when it has a tangent line slope that's above the x-axis, and f will be decreasing when it has a tangent line slope below the x-axis. So let's just find all of the segments of this graph that are above the x-axis. So that looks like to me this piece is above the x-axis, so is this, so is this. Well, right there is our interval of increasing, because these are my tangent line slopes, right? These are all positive x values. Sorry, positive y values. So we can do this like 0, 1, union 3, 4, union 5, 6. That means our other intervals of decreasing are going to happen here and here. Again, these are tangent lines, and we're just looking for the magnitude, These are all below the x-axis. These are all negative values. Think about when you do your first derivative test. You're plugging it in. Those are negative. So decrease, we're going to have from 1 to 3, as well as from 4 to 5. Okay? Now, the next question is asking us about concavity. Okay, so we need when f is concave up and when f is concave down. Okay, that means we care about the slopes of the tangent line of this guy, right? Because the derivative of this guy, the derivative of f prime is f double prime, right? So we should figure out where my lines have positive slopes and where they have negative slopes, right? Okay, so let's see. Let's take our pencil and let's draw on the graph and see when we stop decreasing, right? I'm starting here, I'm decreasing, I'm going down. Ooh, whoa, haha, I hit a spot where I've stopped decreasing. Okay, let's pick a different color for when I'm increasing. All right, here we go. I'm increasing, and then I'm increasing. Okay, so that means I'm concave down from 0 to 2 because I have negative slopes. And then I'm concave up. Let's be careful about saying 2 to 6 because we have this discontinuity here. So let's just be very careful about how we define this and say 2 to 4 union 4 to 6 because we don't know what's happening at 4, right? We have this little, we don't know that it's an asymptote, but there's just something there that's not continuous. Okay, so we have everything we need to know about f to draw a general graph of itself. And we were lucky enough to get a point on the graph, so we can start from this little reference point. Okay, so this is what I'm going to do. I'm going to draw a chart that we can kind of look at to figure out what the shape of our graph is going to look like. Okay, so we're going to consider, let's see, pretty much all of these numbers. Let's do, right here, let me do 1, 2, 3, 4, 5, and 6. Okay. So let's just get this graph going. Okay. So between 0 and 1, the first derivative, well, let's see, from 0 to 1, we said that f was increasing. Okay, so we were increasing. And then, we were positive, which is, increasing sign. That was right. And then we're decreasing from 1 to 3. So we're decreasing. Okay. From 3 to 4, we're increasing. 4 to 5, decrease. 5 to 6, increase. Okay, let's do the same thing for the concavity. So from 0 to 2, I'm concave down. And then everywhere else, I'm concave up. Okay, so from here we can get what the shape will look like in all 6 of these segments. So if I'm increasing concave down, I look like this. And then I look like this. To get these shapes, I'm just combining this shape and this shape, right? Decreasing, concave up, increasing, concave up, decreasing, concave up, and increasing, concave up. Okay, so let's get all of these plotted here. We don't need to be super precise, we just have to get the general sketch of it, okay? So we have all of the shapes we need right here, okay? So from 0 to 1, I look like this. From 1 to 2, I look like this. And then I look something like this. And then, okay, remember at 4, we had this goofy thing going on. Its derivative was discontinuous. That probably means we have some sort of discontinuity happening at 4. So I'm going to draw an asymptote, and let's see if that makes sense here. Because from 3 to 4, we have this shape right here, right? So maybe the asymptote does make sense there. Because then from 4 to 5, I have this shape coming down, right? Let's just draw it like that. And then from 5 to 6, I'm back up again. Something like that. It doesn't matter where you plotted this. Like you could have done like this for all I cared, right? You could have done this. As long as you have the general shape and you didn't violate any of the terms that you found up here, you should be good. So typically on an exam, hopefully the grader will be looking at your solutions for A and B and then judging your graph based on that, like if you got something wrong. But just be super careful when you're extracting this information, especially because this was the derivative graph and we were asked stuff about f. So we had to be super